Hi, and thanks for tuning in to this session all about what's new in Storage Spaces Direct. I'm Cosmos, and I'm joined in studio today by Adi from the Storage Spaces Direct product team. Adi, thanks for being here.
Thanks for having me.
So tell us a little bit about what you work on.
Yeah, so I'm a PM on Windows Server, and my job is to make sure that Windows Server is safe and reliable. And that involves figuring out how to monitor issues, improving the health service, improving our diagnostics tools so that in the end, troubleshooting is very easy and faster for you.
So that's a pretty important charter. I'm sure it's been a huge focus for the team.
It has. People have asked for a lot of visibility in this, and so we've delivered a lot of features for this in Windows Server 2019, as you'll see soon.
So one of the things with Storage Spaces Direct that works a little differently from a conventional cluster, and this is true really with any software-defined storage, regardless of the vendor, is when you restart a server, now there's this different behavior where it needs to resync, right? Can you tell us a little bit about what that is?
Yeah, really good question. So in Windows Server 2019, we added a lot of visibility into this. To explain this functionality, let's start with a very simple example to go over what resync actually is, so that we can make sure that we have the same shared understanding. Suppose that we want to store the word hello. Here we see the bit encoding for the word in binary. So we currently have a single copy of the data. If we enable three-way mirror resiliency, we'll see 3 copies of the data. Now, suppose, for this example, that one server is temporarily down and can't be accessed right now. Because of this, we can't modify the data in copy 1. But now, let's say we want to update our data. We want to update the string hello to help. Now, our bit encoding obviously changes. And since server 1 is still down, we can't update copy 1. But we are able to update copy 2, and we are able to update copy 3. But now you'll notice that copy 1 is stale. It's out of date. And that data in copy 1 needs to be resynced from copies 2 or 3 when server 1 comes back online. And so what we do is we store this state in the dirty region tracking so that it's helpful when server 1 comes back online, we can check it and read and overwrite the data. Now, this provides a working explanation of how resync actually works. But as an administrator, what do you actually see? Well, let's take that same 3-node setup that we've been discussing. The first thing that you'll see is server 1 going down for maintenance. And when server 1 comes back online, you'll see it slowly resyncing that data from other copies. This will take some time, but when it's done, you'll see that all of your storage is back in sync.
Okay, so that's reasonably intuitive. As an administrator, though, in Windows Server 2016, I believe you had to run like a PowerShell commandlet. You had to say, I think, get storage job, and that was kind of kludgy. Has that changed?
Yes, it has. So you're right. If you look at the output of get storage job, it's really difficult to know when resync will finish, how much data is actually being synced per server, and which servers are in sync. So the first thing that we added was giving you more clarity into what's actually happening under the hood. So in Windows Server 2016, you would see that your server was up, then down, then back up again. But in Windows Server 2019, you'll now see that your server's up, down, resyncing data, and then back up again. The next thing that we did was health shows you a warning in Windows Admin Center and in PowerShell when you run get health fault. And this warning tells you when any data is being resynced. And the last thing that we did was if you go to Windows Admin Center under the server view, you can see on the bottom center in the storage graph how much data needs to be resynced per server. And so you can monitor this on a per server basis and understand when your storage resync is actually complete.
Now that's much more intuitive, right? So I can see it directly from the dashboard. I don't need to drop into the command line. And I can think about it on a per server basis as opposed to having to kind of read the tea leaves with a bunch of jobs. That's a huge improvement.
Thank you. Yeah, that's exactly what we wanted to do. It was a hard problem, but we wanted to give you more visibility into the system.
So storage resynchronization is sort of a software concept, but a hyper-converged infrastructure with Storage Spaces Direct is actually a combined hardware-software system, right? So on the one hand, you've got, 4 or 8 or however many servers running Windows Server, but you've also got like potentially tens or hundreds of drives whose performance is critical to making sure that the system works well. And hardware does eventually fail, of course. So how can I look out for that?
So there's a 2-part answer to that. The first is that you're right. drives are expected to fail all the time. And that's why we built some new visibility in Storage Spaces Direct to give you more insight into this. There's two cases. The good case, where a drive is working well, and then all of a sudden the drive starts failing. And that's good because you have a clear point in time when you know something goes wrong. The troublesome case is when the drive is perfectly healthy, and then at some point you notice a small performance issue. And then the drive disappears but reappears. And you start noticing some weird app issues, and you don't know what's going on. And a little later, things seem to be back to normal. Now, that's definitely not easy to troubleshoot. It gets even more complicated. If you start trying to troubleshoot this, you'll first realize that there's a lot of different media types. There's HDDs, SSDs, PMEM, and on top of that, there's different bus layers and protocols to access this. There's SATA, SAS, and NVMe. And each of these has provided more insight into helping you understand what's going wrong. But none of these solutions are standardized. So if you look at smart counters, they were made for SATA only, and they're made to log some of the I/O issues that you might have. But like we said, it's only for SATA. And in order to look at this data, you actually need to go to the manufacturer tooling and look into it. And so if you have drives from different vendors, you have to download specific tooling for each one. Okay, so what about if you look at some log? So there's the device statistics log, which is for SAS drives only, and that's also not standardized. And for NVMe drives, there's this thing called critical warnings. But again, that's only available on NVMe drives. So there was a consolidation. And actually, one thing I want to note is for NVMe drives, if you actually read their white paper, you'll see that they label their logs as smart health information logs. And that's not to be confused with the same thing as smart counters for SATA. Those are two different things. And so all of this gets really confusing. And so there's a consolidation effort made at Microsoft to make the Get Storage Reliability Counter PowerShell commandlet. But this also had issues. As you'll notice in the screenshot, support varies by manufacturer, and that's because there's different layers in the stack that may not be able to translate all the right information. And the classic example of this is if you have a SAS HBA that's attached to your motherboard, and you have SATA drives that are linked to it. It's hard to translate that over, and so we can't always get the right information in that commandlet. And on top of that, each of these drives is running hundreds of thousands of lines of code. And the firmware interfaces with even more code in the driver. Okay, so there's obviously a lot of complexity here. So what if we just look at the system event logs? We look at the disk logs and look at event IDs 7, 153, 154. You can do that. But that gets even more complicated because if you're running a hyper-converged system with Storage Spaces Direct, you'll have to look at its operational logs, which are 203 and 204. Now, you can also look at perf counters. That usually gives you a good indicator of your physical disk performance. But on top of that, if you're running clustering, you have to also look at the cluster storage disk and cluster storage cache counters because they have their own perf counters. And this list just keeps going on and on and on. And what really makes this problem really hard is the sheer diversity and lack of standardization and the lack simply of a single way to investigate this issue.
Yeah, I mean, you said it right. That is really complicated. That can get pretty involved. And I don't know many folks whose title is, I'm a drives administrator. It's like, no, if I'm in IT, I've got other things I need to be doing. So how does Windows Server 2019 make this easier?
Yeah, so good question. That's why in Windows Server 2019, we introduced a new approach. So rather than what these other solutions do, which is focusing on making sure that the drive isn't doing anything bad, we do something different. We make sure that it's easy to make sure that your drive is doing what we need it to do. And since Storage Spaces Direct is resilient, we can be reactive, which means we don't need to predict drive flakiness or failures in advance. We just need to recognize it so that we can act decisively. So what do we actually need from a drive? Well, we need two things. The first is it should be able to complete an I/O request successfully. When Windows needs to read or write, the drive should be able to read that data or write it successfully. In some cases, there's exceptions to that where failures happen, and we need to be able to indicate those and bubble them up. The second thing is it should complete these I/Os promptly. When doing a read I/O or write I/O, the operation should occur in a consistent, predictable way in a short amount of time. For HDDs, on average, that's 10 to 20 milliseconds, and for SSDs, it's around 1 to 2 milliseconds. That's the average normal expected time. If it takes anywhere much longer than that, then we know that this drive could need to be replaced. So the new drive latency and error statistics, the best part about this is that it works with every single drive that you have. You don't need special vendor or hardware requirements for it. It works with all protocols, SATA, SAS, NVMe, and all media types, SSDs, HDDs, PMEM. And the great thing is it's always on. No configuration is needed. Now, the way that you access it is through a new visualization in Windows Admin Center, which I'll show you soon, and through a new commandlet in PowerShell that operates closely with get physical disk. And the reason why this is so powerful is because we record this data in the right place. We go to the lowest edge of the Windows software stack, and we're able to monitor I/O successes and failures. And using this, we create a latency distribution. We don't just take the average. And so this histogram of sorts has 12 buckets ranging from 1/4 of a millisecond all the way up to 20 seconds. And so for each of these buckets, we categorize your I/Os and we take the hourly maximum and the average. And that gives you basically the right data collected in the right view so that you can figure out what's going wrong.
So you said we can see this in Windows Admin Center, right?
Yes.
Can we see what that looks like?
Yeah, I would love to show you. So this is a demo of everything we've been discussing in Windows Admin Center. So if we open up Windows Admin Center and we go to the drives page, you'll see all of your drives are listed and they're in a healthy state. And if we click on one of them, you'll see that this is an SSD drive. And let's full screen this page and scroll down. At the bottom here, you'll see a new feature for drive latency and error statistics. What this basically is saying that is it's telling you all the data that we're going to be collecting to help you make decisions on if the drive is performing well or not. So let's click Show Latency and Error Statistics. So this successfully completed. And now at the bottom, you'll notice we have some data there. So if we zoom in, we'll see that we're actually showing statistics from the last 100 intervals, and each interval is an hour long. So we're showing the last 100 hours worth of data. So this SSD in the last 100 hours performed a total of 8 million I/Os, and that's read and writes. And out of these, so there was 142 gigs read and 41 gigs written. And the average latency was under 200 milliseconds. That's 200 microseconds. That's 0.2 milliseconds. And the incredible thing is, out of all of these 8 million I/Os that happened, none of them failed. So this SSD is actually performing really well. And if you look at the latency graph, you'll notice that we can select the threshold to see if the I/Os are actually slow. And right now we've selected over 2 seconds as that threshold. We can change this to 64 milliseconds. We can change it to 16 milliseconds. And still we see no slow I/Os. Now that's incredible. Think about that for a second. This disk, this SSD, performed 8 million I/Os, and none of them took more than 16 milliseconds to complete. That means it's performing really, really well. And so if we decrease this threshold to 4 milliseconds, now we'll actually see some I/Os passing through this threshold. So you see 1,000 of these 8 million I/Os actually took more than 4 milliseconds, and that represents 0.02% of all of these I/Os. And here you'll see a graph, a histogram of how many failed per hour. And as we noted before, there's 100 intervals over the last 100 hours of data that we're collecting here. And so the cool part about Windows Server 2019 is we raise a held service fault to alert you when this drive is misbehaving and it's slow. And so the way this fault works is we check if the drive is slow, we check if its peers aren't slow, if they're performing fine, and we check for if this has been happening for enough minutes in a row. And we bubble this up not only in Windows Admin Center, but also, as I said, it's a fault, so you can run get held fault and see it there. But lastly, we integrated this fault very closely with getPhysicalDisk. And so if you just run getPhysicalDisk normally, you'll see now in the operational status if we see some sort of abnormal latency displayed there.
Wow, so that's some pretty powerful functionality. I think I've heard Microsoft also does this in Microsoft Azure, right?
Yes, that's right. And so this type of outlier detection functionality, it's much more advanced than what you typically see from other on-premise vendors. But what we do in the public cloud, it just felt right for us to bring this to our customers and bring that to on-premises with Windows Server 2019 so that you can make sure that you are proactively getting some of these advanced features that are sometimes only available in the cloud.
Wow. Okay, so in Windows Server 2019, we've got new tools so that I can see my storage status, so that I can see if my hardware is performing correctly. That's awesome. Now, supposing I do have some kind of an issue that I'm not able to troubleshoot. So maybe I'm going to need to contact Microsoft or contact my vendor or contact someone that I trust to help me with it. What do I do?
Good question. The last thing that you want to get into is a back and forth running different commandlets or fetching individual logs, because what that does is it allows enough time to pass and eventually that evidence gets overwritten.
Right. Ideally, I just want to do one thing, click one button, and get all of the information that is going to be needed to troubleshoot.
Well, I have good news for you. We've done exactly that. We've made troubleshooting faster and easier with Get SDDC Diagnostic Info. This is our one-touch diagnostics gathering tool, and what it does is it collects all of the event logs, counters, and other information into a single zip. And we've optimized it to run in parallel on your cluster. So on a 16-node cluster, it only takes 5 minutes to gather all of the information you need. And after doing that, it creates a file called the Health Summary Report, which gives you an overview of what components are unhealthy and what you should go and investigate. And we've built this option, as I'll show you, to schedule this to run regularly once a day so that in the worst case scenario, you'll have this historical series of logs and data that you can go off of to see when your system started having errors and failing. And this is an ongoing project that we've developed open source on GitHub. We take a snapshot of every minor release about every few weeks and update the PowerShell gallery. And since it's constantly improving based on customer feedback, we're able to collect the right information in the worst case scenario. So if there's any tools that you've been using or any things that you feel that we're not collecting, feel free to check out our GitHub repo and submit a pull request. Now, our roadmap for diagnostics is a 3-step process. The first step is to help you gather all of the right information so that you can root cause faster and resolve your issues. The second is, once we gather all the information, figuring out how to correlate across layers in the stack to pinpoint exactly what's going wrong. And that's why we added these new health faults, and that's why we give you this health summary report to give you an overview of the unhealthy components. And the last thing is, now we're working on ways to provide insights using commonly known patterns and issues that you might see. Now, what I really want to do now is demo how this experience looks like in Windows Admin Center.
Yeah, let's see it.
So when you go to Windows Admin Center, you'll see in this setup that we have a healthy system with 2 nodes. If we navigate to the diagnostics pane, it'll take a second to connect to your server, and you'll see that diagnostics tools aren't currently installed on your server. You'll see the latest version that's available, and so let's install it. While this is happening, something to note is when you run into an issue, like you mentioned before, your hardware vendor or customer support might ask you to run these tools. So it's good to see that how to use this flow. So now that all of the tools have been gathered, you'll see a rocker switch here to automatically schedule it to run every 24 hours. And this is what we talked about earlier. If we enable this, the commandlet in the backend will register a storage archive job. And what it does is it allows you to create that history of logs and diagnostic information so that when something goes wrong, you can have a whole series of data to reference. Now that the data has been collected, you can go and see this current archive and other archives that you've done in the past, and you can navigate in the Files tool to view this zip. Now, when you go to the Files tool works very similar to File Explorer. And so you can see the same 3 zips that we looked at before. And so if we clicked on the one that we just currently run, we can download it so that we can unzip it and look through it and read this health summary report. And at the same time, just to show you, if you go to the properties of this folder, you'll notice that the size of this zip is relatively small. It's all the right relevant information that you need. And so it's very easy to send this zip once to customer support, and they'll be able to help you out with whatever issues you have, rather than that worst case scenario we were talking about earlier, where you have to go back and forth and collect individual logs, and that just increases the time to resolution.
So with just one click, that gives me that zip file that has everything that's going to be needed to troubleshoot the entire hardware-software stack for hyper-converged infrastructure, like storage, compute, networking, all in one package.
Exactly, and that was exactly our goal.
Oh, that's wonderful. So to recap then, in Windows Server 2019, there are new visualizations to understand the behavior of the storage system, especially like storage resynchronization. And so there's a new chart. You can see it directly on the dashboard in Windows Admin Center, so you don't need to drop into the command line and run get storage job anymore. There's the new drive error and latency statistics, as well as built-in outlier detection, which is pretty neat technology. And then there's this one-touch log gathering, so you can easily get all of the information that you need with just a single click in Windows Admin Center, right?
Yeah, you got all of it. Our goal was to make Windows Server 2019 the most reliable operating system that gives you the tools to easily manage your hyper-converged storage spaces direct clusters. So to find solutions from your preferred hardware vendor, you can visit microsoft.com/HCI. To install and check out Windows Server 2019, you can go to aka.ms/Windows Server. And to manage your Windows Server instance with Windows Admin Center, you can check out aka.ms/Windows Admin Center.
All right, well, that's some really exciting technology. Adi, thank you very much. And for more information about Windows Server 2019, be sure to watch the other sessions of the Windows Server Summit, which will all be available on demand. Thank you very much.